Hi, I'm Carolyn Collins Peterson. Welcome to the Astronomer's Universe, where we take a closer look at what professional astronomers are observing and what they're learning. Today, we're going to explore star birth. When you go out and look at the night sky, you can see thousands of stars. And you might wonder, where do they all come from? The short answer is that they were all born in stellar nurseries, massive clouds of gas and dust. A typical starbirth nursery has bright young stars set among glowing clouds called nebulae, and against a backdrop of thick, dark-looking clouds made of dust particles and hydrogen. The dark regions are called Bok globules and are where stars really get started. The nebula NGC 3603 is a good example of a starbirth nursery. At the center of the nebula is a cluster of hot young stars, all less than 1 million years old. They're blasting radiation out in all directions. That radiation is tearing the cloud apart, sculpting huge caverns in the nebula. It's also shaping giant pillars of gas and dust, which may be hiding embryonic young stars that have only just begun to form. Eventually, the clouds completely dissipate, leaving behind a swarm of newborn stars. NGC 3603 also has several intriguing Bok globules, which are collapsing in on themselves to form new stars over the next hundreds of thousands of years. Starbirth regions are as varied as they are beautiful. Each one has molecular clouds and young stars eating their way out of their starbirth cocoons. Until very recently, it was impossible to look into the veiled areas where stars begin to form. And that, of course, is where astronomers want to see, back to the very beginning of the stellar birth process. The first big obstacle is that gas and dust cloud that surrounds the starbirth activity. Our visible light-sensitive eyes and instruments can't see through that veil of cosmic secrecy. But one way to cut through the gas and dust is to use infrared telescopes and instruments, such as the Spitzer Space Telescope, to detect the heat energy released from a newborn star. Spitzer cuts right through some of the clouds to show how active a newborn star can be. The bright regions in this one are superheated jets streaming away from the star. The red haze is dust, and the white dots are other stars. The dust cloud hugging the immediate environment of the star is still so thick that even Spitzer can't see through it. That region is probably where planets could form in orbit around this hot young star sometime in the future. The second obstacle to seeing stars being born is time. We don't live long enough to see the whole process from start to finish. But models and simulations based on real data give astronomers a pretty good time-lapse view of how it looks. We can use the Sun as an example. It was formed from a cloud of gas and dust beginning nearly 5 billion years ago. The cloud condensed until the center got so massive and hot that the young star began shining. Its jet of material carried superheated gases away into space. The thick cloud of leftover material continued to coalesce, and eventually the planets were born. That's a quick look at the process of starbirth. It created the Sun and every other star that we see, and has played out across the universe many times since the first stars began to shine more than 13 billion years ago. For the Astronomer's Universe, I'm Carolyn Collins Peterson, astrocast.tv.